Hello guys, thanks for watching. Today we are going to look at nice approximations for pi and the golden ratio in Python. So let's go to YouTube Python. Let's look at our first approximation of pi. So now it's loading. Okay, here. Import math. The number is going to be equal to the input of tell me the number of iterations you want this algorithm to do for the approximation of pi, of course. We set summation to be 0 and x to be 0. So what this method is based on a series, which is the sum of the reciprocals of the squares of all the natural numbers, and it approximates to pi squared over 6. It converges to pi squared over 6. So we can obtain a nice approximation of pi from that. So while x is smaller than number, x is equal to x plus 1, the denominator is going to be x to the power of 2, and summation is going to be summation plus denominator to the power of minus 1, which means it's 1 over denominator. So it has to print the square root of summation times 6. Now let's see how this works. Okay, so this is a pretty good approximation. Compare this to pi. Guys, let's go to YouTube Python. Let's look at our second approximation of pi. This method is based on the Leibniz formula for pi, and I'm going to show this formula right now. As you see, it's not a formula for pi, it's a formula for pi over 4. But based on this formula, we can figure out the value of pi. So this is a cool approximation of pi. As you see, since you add terms and then you subtract them, the value for pi gets bigger, then smaller, and that's how it works. It's not a straight approximation. It goes up and down a bit. Okay, so while f is smaller than 1000, I is going to be equal to I plus 1, and if f is divisible by 2, then the denominator is going to be 2i plus 1. It's going to be positive, and else is going to be a negative. So this is how it works. Summation is equal to summation plus 4 times math pow, a denominator, and minus 1. This means denominator to the power minus 1. It has to print summation. Now, what are we going to do? Now we're going to look at our third approximation for pi. And what is this approximation? Well, this is the same as the last approximation, but we are taking the averages of the successive approximations. Pi approx. Okay, cool. Compare this to pi.